There is a country that measures silence between two sounds, that calculates the exact pressure of a shoe against wet grass, that once redesigned the shape of paper itself so it would fold into perfect halves forever. Most people know this country for its cars and its beer, but underneath that familiar story lives something stranger. 13 tools exist that carry the fingerprints of German thinking. Some are in your kitchen, some are in your car, one is on your wrist right now. And not one of them ever came with an explanation of where the idea actually started. Germany built the invisible language of modern measurement through 13 strange tools, and the world has been speaking that language ever since. The Zollstock looks like a toy, a folding ruler made of wood or plastic, snapping open in sections like a bright yellow spine. Every carpenter in Germany carries one, but here's what nobody tells you. The standards built into that ruler were not suggestions, they were legal requirements. A Zollstock that measured incorrectly by even a fraction of a millimeter was not a flawed product, it was a violation. Germany did not just build a measuring tool, it built a law out of wood. And that law said that the physical world must submit to an exact number. No rounding, no estimation, no mercy. Germany had already taken that same thinking somewhere far more personal, into the morning ritual of a million households. Melita Bentz was not trying to change the world, she was trying to fix a bad cup of coffee. In 1908, she took a piece of blotting paper from her son's school notebook and pressed it into a metal pot with holes punched through the bottom. What came out was not just a cleaner drink, it was a precise measurement of flow. The pore size of the paper controlled exactly how fast water passed through ground coffee. Too fast and the water took nothing with it. Too slow and it pulled out bitterness that was never meant to leave the bean. She had accidentally built a tool that measured the invisible boundary between extraction and waste. And nobody called it a measuring tool. That is exactly the point. The same precision that controlled a single drip of water would soon be pressed into the hands of every schoolchild in the country. Every German schoolchild knows this object. A transparent triangle with a straight edge running along one side, a protractor curve cut into another, and a set of degree markings so precise they feel almost aggressive. The Geodreieck is not a single tool pretending to be three. It is three tools that refuse to exist separately. A ruler, a set square, and the protractor merged into one piece of plastic. Because a German engineer looked at a student's desk and decided that carrying separate instruments was an unacceptable waste of movement. But the strange part is not the design. The strange part is what the design assumed. It assumed that a student drawing a line at 30 degrees and the student drawing the same line in a different city should produce results that are mathematically identical. Not similar, not close, identical. That assumption is not a feature of a school tool. That is a philosophy pressed into plastic, and it has been sitting quietly on desks across the world for decades without anyone asking where that assumption came from. That assumption left the classroom long before anyone noticed and landed on a field of wet grass where it changed the outcome of a game. Football looks like chaos. 22 players, one ball, and a pitch of grass that seems to care nothing about precision. But in 1954, a German equipment manager named Adi Dassler looked at that pitch and saw a measurement problem. The ground was wet, the grass was soft, players were slipping at the exact moment their bodies needed to grip. He did not redesign the shoe, he redesigned the relationship between the shoe and the surface. The screw-in cleat was built on a specific calculation. How much pressure does a human foot generate at the moment of a sprint? How deep must a stud penetrate wet soil to hold that force without locking the ankle into a dangerous angle? That calculation produced a tool that most people treat as simple sports equipment. It was not simple. It was a measurement of the invisible contract between a human body and the earth beneath it, and it changed the outcome of a World Cup before anyone understood why. Out of sight and underground, Germany was running the same calculation on something far more invisible, the water moving silently through the walls of every home in the city. Somewhere in your building, there is a device you have probably never looked at directly. It sits behind a small panel or at the base of a wall, turning slowly, silently, without any need for your attention. Most people live their entire lives without once thinking about what it's actually doing. It is counting. Every liter that moves through your pipes is recorded with the same indifference as a court clerk logging evidence. Before precise water meters existed, cities guessed. They charged flat rates. They assumed. German municipal engineers in the 19th century found that assumption professionally offensive. Not inconvenient, not inefficient, but offensive, the way a lie is offensive. So they built internal chambers with rotating vanes calibrated to measure flow down to fractions of a liter. Here is the strange part. A dripping tap and a running one feel completely different. To this machine, they are simply two different numbers. It does not care about the difference between carelessness and catastrophe. It only records the exact amount. What lives in your basement is not a utility device. It is the physical proof that Germany once decided estimation was a form of dishonesty, and then built a machine to make sure no one could get away with it again. Most kitchens have one. A clear plastic cup with lines printed along the side, sitting in a drawer next to the wooden spoons and the bottle opener. It measures milliliters. It measures cups. It does what every measuring cup does. But the German version of this object, the multi-ingredient Messbecher, does something that most people in other countries have never seen on a measuring cup. It measures density. The markings on its outer walls account for the fact that flour weighs differently than sugar, and sugar weighs differently than rice, and rice weighs differently than water. Each ingredient has its own calibrated column. You fill to the line for that specific material, and the weight is already calculated for you. No scale required, no conversion needed, no estimation tolerated. This is not a kitchen convenience. This is a German engineer looking at the act of cooking and deciding that the rest of the world had been measuring incorrectly for centuries. The strange part is that they were right, and somehow the rest of the world still has not caught up. Imprecision in the kitchen was a quiet failure. What came next was far more public. Germany took that same refusal into the streets and attached the hard number to every meter of the journey. Wilhelm Brunn had a problem that most cities in the late 19th century had quietly accepted as unsolvable. Passengers argued with drivers. Drivers overcharged. Nobody trusted anybody. The fare at the end of a journey was a negotiation, not a fact. Brunn was a German inventor, and he found negotiation professionally unacceptable. In 1891, he built a device that attached to the axle of a horse-drawn carriage and converted the rotation of the wheel into a precise monetary value displayed on a dial. Distance multiplied by rate equaled fare. No conversation required. No haggling permitted. The taximeter did not just measure distance, it removed the human element from a financial transaction entirely. That was the strange and radical idea buried inside what looks like a simple cab device. Every rideshare app running on your phone today is built on the same core logic that Brunn pressed into brass and glass in a German workshop over 100 years ago. The meter was never just about money. It was about the German belief that any exchange left to human judgment was an exchange waiting to go wrong. That belief moved quietly from the streets into every office and every desk in the modern world, carried there by something that looks like nothing more than a blank sheet of paper. Cast your eye across any desk in the world and you will find it. A rectangle of white paper sitting in a tray, loaded into a printer, slipped into a folder without a second thought. You have handled thousands of them. You have never once questioned the shape. You should have. The dimensions of that rectangle are not arbitrary. They are the result of a single mathematical decision made by a German engineer named Walter Portzmann in 1922. He built the ratio of the sides around the square root of 2. That one number means that when you fold an A4 sheet in half, you get an A5 sheet with exactly the same proportions. Fold it again, and you get A6. The geometry never breaks. It does not matter how many times you fold it. This sounds like a quiet engineering detail. It is not.
Every printer ever manufactured for the European market was built around that ratio. Every folder, every filing cabinet, every document archive in most of the world was constructed to hold an object whose shape a single German engineer decided in a workshop over 100 years ago. You did not choose to live inside a German geometric standard. Nobody asked you. It was simply placed around you, and the paper has been sitting there ever since, waiting for someone to notice. There is a moment every driver knows. The needle climbs, the engine pulls. The world outside the window begins to blur at the edges, and somewhere on the dashboard, a number tells you exactly how fast your body is moving through space. That number feels natural now. It feels like it was always there. But before 1902, it did not exist. Otto Schultz, a German engineer, was among the first to solve the problem of converting wheel rotation into a readable speed on a dial. The calculation required was not simple. A spinning axle had to be translated into a precise numerical value in real time, accounting for tire diameter, gear ratio, and rotational frequency simultaneously. What they built was not a comfort feature. It was a tool that took the raw physical sensation of velocity and replaced it with a hard, unargued fact. That fact is now law. Every road in the world has a speed limit. Every speed limit only exists because someone built a machine that could prove you were breaking it. Lift your wrist. Whatever is there, a screen, a strap, a dial, carries a story most people have never been told. The wristwatch is the most personal measuring tool ever conceived, and its story began in a German workshop centuries ago with Peter Henlein's first portable clocks. The goal was not just to make a clock smaller. The goal was to make time a personal possession, a number you could hold in your hand. German watchmakers spent generations fighting a war against physics on a microscopic scale. They measured the wobble of a balance wheel and the expansion of a hairspring in the heat. Here we see the pattern again. Germany finds a problem nobody else thinks is a problem, builds a machine to measure it with terrifying precision, and then convinces the world it cannot live without it. The result is the device on your arm right now, a tiny engine of pure logic ticking against your pulse. You do not just wear a watch, you wear a German philosophy that says your life must be synchronized to the second. This obsession with capturing the unmeasurable did not stop with time. It turned its gaze to the very air around you and asked a question that once seemed impossible to answer. What is the exact number for the feeling of cold? Daniel Gabriel Fahrenheit was not a scientist chasing fame. He was a German-Polish instrument maker who found the existing ways of measuring temperature personally offensive. In the early 1700s, temperature scales were inconsistent, unreliable, and different depending on which country you were standing in. Some used wine, some used water, some used the temperature of a human body as a fixed point, as if a human body was a reliable standard for anything. Fahrenheit looked at this chaos and decided it was unacceptable. He developed a scale with fixed, reproducible reference points, points that did not depend on the mood of the weather or the health of the person holding the instrument. He filled the glass tube with mercury and calibrated it against a freezing brine mixture at the bottom and human body temperature at the top. What he produced was not just a thermometer. It was the first argument that temperature is not a feeling. It is a coordinate, a fixed address in the physical world that exists whether you are there to feel it or not. You have been living inside that argument every time you check the weather. Every medical thermometer that has ever been pressed against your skin was asking the same question Fahrenheit asked in 1714. Not how does this feel, but what is the exact number? Behind that question lives something older and stranger, a swinging weight in a wooden case that had already been keeping the world honest for 200 years. Christian Huygens built the first pendulum clock in 1656, but the German watchmaking tradition that followed did not treat his invention as a finished idea. It treated it as a problem that had not yet been solved precisely enough. The pendulum is not a part of a clock. It is the argument the clock is making. Every swing covers the same arc in the same time, not because someone decided it should, but because gravity and length make it mathematically unavoidable. You cannot argue with a pendulum. That was exactly what German clockmakers loved about it. So they measured. They calculated the exact length of wire needed to produce a 1-second swing. Then they noticed that heat expands metal, and expansion changes the length, and a changed length changes the arc, and a changed arc changes the time. So they measured the temperature of the room as well. They were not building furniture. They were building a proof, a physical demonstration that time does not speed up when you are bored or slow down when you are afraid. It moves in identical units forever, and a piece of brass on a wire can prove it. Every train that has ever left on time carries that proof forward. Every schedule you have kept, every appointment you have made. None of it was a cultural habit. The world did not learn to be punctual. It was measured into punctuality, one identical swing at a time. Consider what is happening beneath your car right now. 4 columns of compressed air, each one invisible, each one holding several hundred kilograms of metal and glass and human body off the surface of the road. The margin between the correct pressure and a dangerous one is measured in PSI, pounds per square inch, and most drivers could not tell you what their number is. That gap between ignorance and precision is exactly where the tire pressure gauge was born. German automotive engineers in the early 20th century were building faster cars than the world had ever seen. Speed created a new problem. At high velocity, an underinflated tire does not just feel soft. It generates heat through friction, and that heat builds until the rubber fails without warning. They needed a tool that could reach inside an invisible column of air and return with an exact number. The gauge they developed used a calibrated spring inside a sealed cylinder. Press it against the valve, and the air pushes the spring back a precise distance. That distance translates directly into a pressure reading. It is a tool that makes the invisible argument proof. It takes something you cannot see, cannot feel accurately, and cannot guess reliably, and hands you a number. Germany did not build this because cars were interesting. It built this because imprecision at speed is not an engineering problem. It is a matter of whether you arrive. What connects a folding ruler to a coffee filter to a sheet of paper to the air inside your tires? On the surface, nothing. They belong to different worlds, different centuries, different problems. But underneath each one runs the same current, a refusal. A specifically German refusal to accept that close enough is ever good enough. These 13 tools were not built because someone wanted to be clever. They were built because their makers looked at the world and found it unacceptably imprecise. The Zollstock did not just measure wood, it made imprecision illegal. The coffee filter did not just clean a prank, it standardized an invisible physical boundary. The pendulum did not just keep time, it turned time into a provable fact. Each tool was a small argument made in metal or glass or paper, and that argument has been running silently inside your daily life without credit, without acknowledgement, and without your awareness. Your GPS coordinates exist because someone once decided that position could not be estimated. Your medical diagnosis rests on instruments calibrated to standards that trace back to German workshops. The bridge you crossed this morning was built to tolerances developed inside a tradition that believed a millimeter was a moral category. Germany did not export a culture, it exported a standard. And the strange truth is that you have been living inside that standard your entire life, speaking a language of measurement you never knew was invented. These tools are only the ones that survived long enough to reach us. Countless more are still sitting in drawers, workshops, and museums, waiting for the next person willing to look past the ordinary and see the argument hiding inside.